Welcome to the third lecture on gas laws. And you're thinking, oh, I've seen that before. Okay, this is what we call the general gas law. And all this is just still the derivation of our ideal gas law, where we've actually changed the conditions. Some teachers will make you want to prove it. Just set everything to NR, because that's not going to change, and just make it two conditions, and it sets equal to each other. Now, one thing about this, when you're thinking, oh, what about Boyle's? What about Charles' law? What about Guy-Lussac's law? If you remember, one of those three is held constant. Okay, one of those in Charles is, I got volume and temperature. The pressure is held constant. Boyle is volume and pressure with the temperature held constant. Guy-Lussac's is the pressure and the temperature, the volume held constant. I can remember three equations, more equations, but if I start with this one and I just have pressure and temperature for Guy-Lussac one, I don't need to put the volume in. Three less equations to remember. You can do this. Just make sure it's okay with your teacher. One thing nice about this, that the volume and the pressure can be whatever units that's in the problem. You do not have to change your volume to liters or your pressure to atmospheres. It's just make sure they're the same on both sides. Now on this one, just as any gas laws, the temperature has to be in Kelvin. Just remember that. Temperature in gas laws always has to be in Kelvin. So let's look at this, okay. Since we're going to look, okay, I don't see anything about moles. Don't use that one. No molecular mass, can't use that one. So, as I say, door number one, moles. Door number two, molecular mass or mass. If it's not door number one, door number two, this must be door number three. So that's V1, P1 over T1, V2, P2 over T2. Just 1 and 2, just make sure that this is your initial, 2 is your second one, or your final set of conditions. You might see a V, an I, and an F, or something of that nature. Just look at what your book says, but this all says the same thing. Okay, we don't have temperature, so the temperature must be held constant. So, well, if you really want to do this, you can put 1 in here, knowing it's not going to change. So volume, 35.5. Okay, the pressure, so just that's one set, so make sure you just keep them the same. Okay, it says, what is the volume? V2. Okay, the pressure is at 740. Oh, that wasn't bad. And then we just solve for V2 and just keep in the same units. And that's really the main thing about this. Here's one with volume and temperature, which is a typical Charles's law. Okay, nothing about pressure, but I don't see moles or molecular mass, so I can't use those. Now some books may say P1, V1. Don't panic. I've been known to write them that way too. Okay, so no pressure, so the pressure is held constant. So the volume, I got 400. Now remember, temperature in gas laws must always be in Kelvin degrees, so add 273. Okay, I want V2, and at 50, and there it is, and V2 is in milliliters. And then you can just work your way through these. But you're looking over here and it's a, STP. Okay, let me just kind of write up here. STP is standard temperature and pressure. And when your teacher gives you that, he or she is actually giving you the temperature and the pressure of your sample, or what you need to. So temperature will be 0 degrees Celsius, which, remember, always in Kelvin, is 273 Kelvin. And the pressure is 1 atmosphere, which is same as 760 millimeters of mercury. And remember, when we had to change the millimeters of mercury to atmospheres, you use that. You might see 760 torr for good old Torricelli. And if you're in kilopascals, it's 101.3 kilopascals. So, and you would use these depending on the pressure in your first one. Okay, let's look at one with STP. Okay, under pressure, okay, got B1, P1 over T1, B2, P2 over T2. Okay, 25.0. Okay, the pressure is 500, and the temperature is 25 degrees. Don't forget 273. There it is right there. Okay. Now, we want the volume under STP conditions. Okay, you look up here, which ones to use? Well, let's see, my pressure is in millimeters of mercury, so I need to use 760, since that's in millimeters of mercury, and the temperature is 273, which is a given. So V2, okay, my units will be in milliliters. Okay. Now, we could take it the other way. Let's go and write the equation down. Oh, that should be a 1. Got a little carried away. There we go. Okay. V2, P2 over T2. There we go. Okay. So, what we do, we have a gas sample under STP conditions. Well, that tells us, well, let's see. Okay, what units, for which one of my pressure? Okay, millimeters of mercury, so that's going to be 760, and that's 273. Okay, set the, okay, now that's V2, 770, and then there's 30 plus 273. Oh, that wasn't bad. Okay, just remember STP, so you might want to commit those to your memory. And in milliliters. Well, no, didn't read. It has to be in liters, since that's what I started with. I do make mistakes. Okay, and that's the reason why I use a pencil when you work math or physics problems or chemistry problems, unless you have an erasable pen. That doesn't look pretty, does it? Okay, so remember gas laws. If you see moles, PV equals nRT. If you see mass or molecular mass, use this equation right here. And if you don't see moles or molecular mass in your problem, there it is. Yes, there are some more, but these are the basics. Good luck. Enjoy.